Hello, welcome to my tips and techniques presentation for Java and SQL database by Seth Kolb. Databases store data in formats using keys and values to save data. Organizing structured data into data tables like columns and rows. Unstructured data is a format of data that has no structural pattern to hold to it. Structured data means if the data is being organized into a predefined format. Here are some examples of stored formats. JSON is unstructured data, XML is semi-structured data, and SQL is formatted to hold structured data. The example image is shown is a SQL database that has linking data tables to retrieve data from each other. SQL, structured query language, is used to manage data in relational databases. Also, a user using SQL queries the data that is needed from data tables to get information the user needs. A user can store, retrieve, update, and manage data. SQL has a strict syntax, but is easy to learn. SQL data table columns are usually organized by IDs that stores a key identifier for each row within the data table. Here is some SQL syntax. Use select to read or retrieve data, utilizing where to find the table, insert to add more data into the table, use update to modify data from an existing row, delete to remove data from a row that's already existing. Some SQL database management services are MySQL, Microsoft SQL Server, Postgres SQL, Oracle, and SQLite. SQLite is a local database service implementation of SQL. We will be using SQLite in the demonstration soon. Within an system, it's important to receive and store data easily and efficiently. And within big systems, it's important to have this since they need reliability and speed when dealing with a big user base. Companies all over the world use SQL all over many industries, and massive companies like Meta, Google, and Amazon utilizes SQL. For this demonstration, I'll be focusing on creating a table, inserting, and reading data. I'll be making a song database. I'm going to start with creating the layouts for the main activity where the songs and music artists will be displayed using a recycle view where we'll be creating a card view holder for each song entry. We'll also set up moving between the main activity and the add song activity that will handle adding a new song to our database based on the artist and the song name that we provide. Now, since we're set up to move between activities, we are ready to create the SQL database. Extending this class, providing SQLite Open Helper, which helps to give our class the database functions and logic that it needs. There are functions in the constructor that we'll need to include to our file. We're going to add, we're going to set up variables for name and the version of the database to provide it inside the constructor. Also set up our column with providing the ID of the column and other variables of other column variables like song title and music artist. Now we will set up creating the table. We will store our query inside of a string. SQL is very strict using literal strings to create the table. We use the create table syntax shown in the presentation and providing our variable column ID and the other variable columns we created. Then execute the query to our database that we passed in to inside our function. I will set up a debug with Toast to see if either inserting the data will fail or succeed later, to check the data itself, making sure that our SQL database is able to query properly and doesn't crash. We will use insert to write our variable data column variable data into our database that we will input from the add song activity with our edit text. Also passing through the string inputs for the title and music artist through our method. Also displaying the debug to see if our table is set up properly. Now when we hit the add song button inside of our add song activity, the it will pass in our inputs for our music artist and song into our add song method. It looks like the database was able to get our debug for our insert. It looks like that the table was set up correctly with our queries. Now we will work on reading all of our inserted data from the table. This will take a lot of setup. We can go to store our raw database query inside of a cursor, then have it read by our recycler view that will create card views. For that, we're gonna need to make a layout for our card view and create a custom adapter class. We will set up all the necessary functions and methods for our custom adapter class, and we will store our column values inside of our array list so we can pass them into our custom adapters constructor. And then we will start working on our card view holder. Inside of the card view holder, we will set We will just set up text views for our ID of our column, the song the song ID text, and the music artist text. We will set up a public class inside to get our text edit properties. Then then set the text of the variables of the card view holder. We will need to pass in the song ID count inside of the item count return. Then inside of the create view holder, pass in our class that we have of the my view holder that we have the text edit IDs set with the car view holder. In the main activity, we will create a reference to our music database class and get our cursor and create an array list for all of our column variables. Then add our column data to our array list, which the number passed in the column row, which I forgot to change the correct columns for the song title and music artist, which you'll see soon. That will just show the numbers. Now we will create our objects inside of the populate song list function. Then we will call our store song array list, and then we will pass in our arrays into our custom adapter constructor before we create our card views inside of our recycler view. We need to call populate song list on create, and I also have it on resume to repopulate the list when I return from the add song activity. What I forgot to do is to make my array list to add the first and second column for the song title and music artists, because when populate it only populated all the text edits with the song IDs. So that's why it popped up only one. The last thing I did was to make sure my card view constraint layout height was wrap content so the songs would stack nicely on top of each other. And I added text view labels at the top of my main activity layout above my recycler view to be able to know the categories that are visually shown. Some pros for SQL is speed, reliability. They can communicate and quickly query between different different relational databases. It is built to be scalable. Some cons of SQL is that it follows a strict structure when writing for SQL. It takes complex management for bigger databases and takes a lot of complex setup for optimization for more advanced queries, and SQL struggles with handling semi or unstructured data like JSON or XML. With scalability of large databases, it might be harder to run on devices. Here are all the resources I used to create this presentation and to help create the demonstration that I've made.